Okay, so this is our lesson for this week.
Yeah,
I'm
I
going to
don't know
use this Jamboard since we're home and I don't have my document camera. So let's see if we can't fill in things here and make this work.
Wednesday.
So let me
It
look
might
at
get
our
to
options
35.
in here. Okay, so this is looking at quadratic functions and we're looking at all the things that can cause transform.
we don't.
Now we know just a standard quadratic function
if
would
we
be
don't ever get
just
the sun out,
x squared.
this is not
Right?
going to get better.
fx equals x squared, what we call the parent function, because that is without any transformations at all. It's just straight up right there. It has that in the top corner up here. Let's see.
He wants his like octopus screen.
And that's
so
the
he can
parent
see
function.
all the-
F of x equals
That
x
is
squared.
nice.
That's the
Yeah.
graph of that. It just
Yeah.
goes through the origin, and you see the parabola going upward from,
But it is
from the origin vertex.
weird out there. I
That
mean,
is the
it's
parent
not.
function.
It looks like
So,
snow, but it's
in
little balls of
vertex form,
ice. So I don't know if
change this
it's
over here.
acting like snow or how it
Okay,
acts
that'll work.
under
So the
the
vertex,
tires or.
looking at this formula down here,
Actually
if
talked
there
about
is
how
an
weather looks
HK,
like. They said if you'll go really slow, it
that
kind
will
of
be your
rips
vertex.
tires
So
because
in,
of
like in
the
this case, the parent function, h is 0 because there's nothing being subtracted from the x, and there's no k
Right.
being added on, so it's 0. So 0, 0 is the hk. So that is the parent function. And then the axis of symmetry
Don't use your brakes. If you
would
need to
be
stop, too
x
bad.
equals h. So the axis of symmetry is whatever the h value
Okay.
is, which in this parent function again
Well,
is 0. So
I'm thinking
x equals
once
0
the
is
temperature gets high enough, it's going to start melting and make things worse.
So,
Yes,
all
and
right.
then it's gonna drop.
Now let's talk about what the a
So
and the
there'll be a
h
solid
and
sheet
the
of
k
ice.
do to our parent function.
Yeah,
All
fine.
right, so the a would be out in front of it. Like if instead of x
Well,
squared, it'd be like
fun little
2x
story.
squared or 1/2 x squared. Or
The school isn't
5x
contacting
squared.
us if it's not
So
calling
here's what
us.
happens with our negative 2x
So
squared.
we got up
So let's
and
put
left
this,
the house yesterday morning because we thought there
put
was
this up
school.
here.
So
So if the
I looked
a,
down and I thought, the road looks a little
the a is
slick.
greater
Like,
than
it looks
0,
a little shiny.
first off,
I was like,
it will open
like it
up.
wasn't.
all right, so
White
it'll go up
anywhere.
like this right here.
And then we got in
However,
our car and we slid down
If
the
the a
road.
is less than 0,
And my husband said, "Did we
Then
have
it goes
school
down.
today?" I was like,
so
"I'll
that's
start
how
looking."
you reflect it over the x-axis. If
There
you
was
put
anything on the
the a
website.
out
It
in
wasn't
front,
anything
even if
on
it's
the
negative
district
1, it's just
website or the
negative
school
x
website.
squared,
I was
it would
like,
reflect it
I don't
downward.
know. Finally,
So let's
for
look
some
over
reason,
here.
I found Twitter. I was like, we don't have
Also,
school.
if
By
the
that time, we were already at the highway.
I lost my. Here we go.
And so then we got off the
I
next
really
exit
can't put
and came back
absolute
off.
value. I want to move this over.
I had to
It's
go
kind
to
of outside of
school
our
because I
box
left
here.
my
But I'm
laptop.
going to move it
And I
over.
was like thinking we were going to have school yesterday.
Absolute
We had to take
value.
it home Friday.
I can't make the little
and
absolute
I
value
knew we
symbol with
weren't
this
gonna have
typing
school
on it.
today.
The
And then
absolute
we probably
value
did a
value,
virtual thing.
if it's
So
greater than
I
1,
had to go about 7:30.
then this is
so I
a
had to go
stretch.
now.
Mm-hmm.
And we'll look at
When I was
this
there, I ran
on
into 2 or
the
3 other people
samples
doing
going to
exactly
change.
their stuff.
Uh,
But it was
okay, so if the A value,
time I left and time I made
the
my
absolute
phone.
value of the A value,
And it
which
was
means
huge.
whether it's negative 2 or positive 2, the absolute value is 2. If it's larger than 1, then it's going to,
Wow.
Well,
then it's going to stretch it, which means it's going to pull it out
10:30, you're kind of
faster. It's going to go up faster.
Yep.
If it's less
Well,
than 1, if
I
it's
thought
like a
this was easier than
0.3
making a
or
video
negative
because we don't
0.25
have.
or something, it's going to compress it. So those,
Like
those
I have an
arms, they
X
get
pen,
pushed
so
down,
I
it's gonna
can
be
write,
shorter,
and it shows on the
for
screen, which
each
is
point
what I really
than it would have been
need for this
otherwise.
lesson.
So
And I know there's Jamboard
again,
on
we'll look
here,
at some examples of that.
which I will use if
Now
I
let's
need
look at
to.
the
But
H down here.
I thought this was just easier than making
X
video.
minus H in parentheses squared. So it's not just X squared, it'd be like X minus 1 squared
Yep.
or X plus 4 squared.
Yep.
So with the H,
Yep.
down here,
have a good day. and
Half of
stay
the-
warm.
if
Yes, half of them
H
probably aren't
is
even up yet.
greater
so.
than
No, they're
0,
not awake.
Yeah.
then
Not at all.
it moves it to the right.
And if
I'm
they
gonna
are,
make that
they're
an
not
arrow.
going to
See.
do.
If H is
They're not
less
like, "Oh,
than
you just agree."
0,
It's not.
Mm-hmm. Yeah, they'll be doing the
it's
easy
going to
things
move it
first.
to the left.
But I have had a student already email
So when you
me,
have X
so-
minus H, if the H is greater than 0,
You know,
it's going to move it to
They're
the
not
right.
new to
And
this.
X is less than.
Right.
Now here's where you have to be careful.
Yep.
I'm
Yep, they know the
type
drill.
this up here.
They know the drill. That's right.
Be careful with H.
All right.
I'm gonna
Bye.
make this wider over here too. Be careful with H. If H is greater than 0, say for example, like H equals 3, it will appear in the equation as X minus 3. That's what you'll see in the equation. And you're like, wait a minute, I thought H was greater than 0. That's a negative 3. Well, if you look at the standard formula, it's X minus the H. X minus positive 3. If it was a negative 3, if H equals, H equals negative 3, then it would appear as X minus negative 3, which is X plus 3. So you're going to see a plus 3 in the equation if X is negative, if H is negative, because it's X minus whatever H is. So if H is a negative, it's going to show up like that. So it's going to fool you. You're going to glance at it real quickly and you're going to see X plus 3 and you're going to think H is greater than 0. But that would be incorrect because it's X minus whatever value of H is. So don't let that fool you because it can do that. Let's see. Down here, let's look at the K, which is afterwards. K is greater than 0. And K is less than 0. Let's look at the two options there. I'm going to get this. If K is greater than 0, then it's going to move up. If it's less than 0, it's going to move down. Just a translation up or down. So let's look at some of those samples. Right here. Okay. We're gonna graph this. X squared plus 3. This is a perfect example of a K right here because we didn't change anything here. A and H don't affect anything. A is just 1 apparently because we don't have an A, and H must be 0 because we're not subtracting anything from that. So this is just X squared, which is the parent function, adding 3. So when we add 3 to the parent function, let's see what it does over here in our chart. So for our chart, we're going to type, if it's negative 2, back here. So that means it is negative 2 squared plus 3. Right? So negative 2 squared is 4. 4 plus 3 is 7. So our y is 7 when x is negative 2. When it's negative 1 squared plus 3. So negative 1 squared. Negative 1 times negative 1, that's a positive 1, plus 3 is going to give us a 4. Okay. So the 0 is pretty easy. 0 squared plus 3. All right, that's just going to be 3.
Hi, Blake.
Hello.
I saw your
Blake is minutes
email.
class.
Just haven't done anything about it yet.
That was the class on the other side of the table from me. 1
Would
squared.
you like to
3.
go over it now and see what you
So
did
that would
wrong
just
with
be
this?
Also 4.
Yes.
And then
Okay.
the last one
Also,
we have
what'd you
down
call
here
for?
would be 2 squared.
First
Ah!
thing I called for
That was scary. All right, 2.
I don't think the particle molecules.
Let me type in that. 2 squared.
Okay, green spheres
Plus
represent chlorine
and that
atoms.
would
Yellow
be
green
again a
spheres
7.
represent fluorine atoms.
All right,
and
so we're filling
white
this in.
spheres-
So here
spheres
is
represent
our
hydrogen
points.
atoms.
Negative 2, 7, negative 1,
Okay,
4,
so you know that's not
0,
today's
3.
assignment, right?
1, 4, and 2, 7. So let's start by graphing this 0, 3. 1, 2, 3.
Let me make sure I attach
Right
the right
there.
lesson.
see if we can make that a bigger pin. There you go. And let's do it in red. So 0, 3, we'll make it right there.
Okay.
That's doing something weird.
I saw the bell work, and I think I don't see anything
Roll a
else
paintbrush.
for it.
Let's try that. 3.
Okay.
And then
Are
we
you
need
looking on
negative 2,
week
negative 2,
23?
positive 7, negative
in
2,
Google
1, 2, 3,
Classroom?
4, 5, 6,
Week
7.
23, Google Classroom, balancing
Oh, it's
equations.
making it the highlighter or something.
with the
weird. Let's
FET?
try this.
So this is the simulation you're supposed to be doing today.
Okay.
And negative 1, 4. So
Yeah.
it would go.
I already did that, though. I think. Yeah, I already did that.
Yeah, I realized that we started it in class, but not many people
Put
had
arrows on the end of it.
finished. And since I thought, oh, we've already started,
Okay,
you
so
already
that's
have
what a graph.
instruction
Now,
on
if we
it.
compare that
just
to
go ahead
our
and
x squared
finish
graph,
it.
which is right here, right? We see on the x squared graph, it has
But
the
other
origin at
thing
0,
for
and it just goes up.
I don't want to do this one.
This one has the, the vertex is down at 0, 0.
Okay.
This the vertex is at 0, 3.
let me
The
just
only thing
look.
difference between this graph and the graph on the other page is it went up 3 because the k was greater than 0. The k was a positive 3.
Yes.
So when it was a positive 3, it went up.
Yeah,
3.
I don't have my headphones on yet. So,
So-
yeah, you're hearing all of him. Yeah.
Vertex here is 0, 3.
Okay, Blake.
Axis of symmetry.
Looking at the assignment for
So that would
today
be
that you
x
turned
equals
in,
0 because it's the h, right? And the h is still 0.
and
The K changed,
some
but
of
H is
it
still
is
0.
done, but not all of
And then
it.
the y-intercept. In this case, the y-intercept is the same as the
Questions
vertex. 'Cause it
4
crosses the
through
y-axis at the vertex. How's this compared to
I'm
the
gonna
parent function?
submit that.
Yeah,
Let's
9
answer
through
that.
11 are not
So
done.
typing, how does this compare? The
Or no, 4
parent
through 11.
function,
Okay.
which is x
So you
squared,
did question, no. Okay. You did
is
question 2 and 3, and then you balanced the ones at the
shifted up
end, but
3.
you didn't do anything in between.
That's what it is. The parent function, x squared, is shifted up 3. That's the only difference there. So that's what the k does. When you see a +3 or a -7 or +1 or -0.5, whatever, that just moves it up and down. Okay, so we're looking at translations, dilations, and reflections here today. So let's go to the next example. Horizontal translations. Okay?
Well, just finish
This
it.
is
Just
where we've got an
unsubmit it.
h that's in
Finish
there.
it.
See, we've got
Yeah.
x minus
So
h
you-
squared.
I know you did the
So
hard
we're just
part.
looking at this portion of the equation. What happens when we just change
Yeah.
the h? We're not changing anything else except just the h, so we can see that. So let's put in our table over here.
And the quizzes thing with the other thing.
So what we see here is this
Right.
is
I haven't.
the
That's
x
on my list to do.
is 0. So 0 minus 2,
On my list to do.
0
Oh,
minus
there
2
we go.
squared.
Just
And
gonna
0
write it
minus 2
down.
is -2. -2 squared
And I will get to
is
that
4.
sometime today.
Okay,
Oh, no.
let's look at the next one.
Um,
This one's 1 minus 2 squared. So 1 minus 2 is -1.
Hello? Can
Negative
you see
1
me?
squared
Oh,
is 1. All right, so just doing the math. We're just
I don't know, it just
substituting
plugged
these
that
x's
hole.
right here into the equation
okay.
and solving.
All right. Let's do one thing at a
Let's
time.
do
here.
another one. So
Look at the
2 minus
assignment.
2
Is there a reason why you
squared.
didn't do some of the questions?
0, right? 2 minus 2
I
is
think
0.
at the
0
time,
squared is 0.
I think it was due at a
And then we'll
certain
do
time. It's like, oh, we're
3
gonna get
minus
it done. And I
2
just hit submit,
squared.
and it's like,
3 minus 2 is 1. 1
I
squared
don't think
is
I really
1.
thought it through that I didn't
And
complete
then
everything.
Last one
Okay.
here. 4 minus 2 squared. So 4 minus 2 is 2.
Okay. Trying
2
to figure
squared
out these
is 4.
headphone options. Not
Okay, so there's our point. 0, 4, 1, 1, 2, 0, 3, 1. So let's
Okay,
graph this
headphones
one.
are-
little earbuds.
So
Trying to
0,
figure out
4,
how to connect them
right
to my
here,
computer.
and it goes down to 1, 1, and it goes down to 2, 0, back up to 1,
Or
1,
if I
back up
need to
4.
connect them to Google Meet.
Okay. I didn't draw it exactly straight in there, but I tried. So basically what has happened is the vertex is now moved Where's the vertex? The vertex is over here at 2, 0. That's the middle point. That's the part where it turns around like a reflection.
Where's the blue too?
The axis of symmetry is, remember, it's just
Okay.
x equals whatever the h is. The h is 2.
Oh, that's something for later, I
I
guess.
don't need the parentheses for that.
Okay.
X equals 2 is my equation for that.
So
And
you
the
want to
y
know,
intercept.
okay, so the assignment
y
that you
intercept
came on
now is at
asking about
0, 4.
will be your Thursday assignment.
You see, when the x
And
is
if we
0,
have
when it crosses the y, and that's 0, 4.
School, I won't be
So
there.
0, 4.
So
So
if
how
we
does
have
this compare to the
AMI,
parent
then
function?
I'll be here,
Okay, so what
but
happens?
just in case, let's go ahead and talk
Parent
about it.
function x squared
I am going to, let's see.
is shifted
What
right,
we need to
2.
see.
right? When we put that
Okay.
2
Let me
in for h,
pull up
it shifted it to the right 2.
the
Parent function
assignment
x
so we
squared is shifted right 2.
can talk about the same thing together.
See, this is exactly like this original one right here, except for the vertex and everything, all these points, every point went to the right 2 spaces.
He's a virtual teacher,
spaces.
so
You get to hear this all the day long.
yeah, a lot longer than
Only when we're home.
what grades do you teach? Do you have sophomores through seniors?
Mainly juniors and seniors, but we
Juniors
do
and
have a
seniors.
few freshmen and sophomores in some of my classes. Special programming, I have.
Yeah, he's got coding too, so.
All right, let's look at this last one. Dilations and reflections. We looked
Okay.
at horizontal translations. We looked at vertical
So
translations.
which one are we talking about?
Let's look at a dilation or reflections here.
If green
So this is
spheres
gonna be a
represent
dilation.
polar
This is not a
gravity,
reflection.
Yellow-green spheres represent fluid
Remember,
gravity.
How did you do
if A,
How did you do the
if this
two
1/3
above it?
was below 0, if it was a negative 1/3, then it would be down. That would be a reflection. This one is a positive 1/3, so it's not going to be a reflection,
What
but
did
it's going to be a
Let's
dilation.
back up and
So let's put
Okay.
our
let
table
me
in
see if I can
here.
copy and paste onto.
So we've got
Jamboard. That would be
1/3 times
Let's see.
-3.
Okay, start a new whiteboard.
So we have to put a y out here on the side. So -3 squared is 9, right? -3 times -3, and 9 times 1/3 is 3.
Okay,
So
we're
the
gonna-
y is 3. Let's do another one over here. This type's really big.
It's a
And -1
it's a
squared.
dial.
So -1 times -1 is 1 times 1/3. So this
And
is
then
1/3.
So what do I?
I gotta open that bigger.
Can you see it?
So when x is -1, y is 1/3.
No.
No.
Yeah, let's go over here.
Okay. It said view on your
1/3
side.
times 0 squared. 0 squared is 0 times
Yeah,
1/3.
close it and
Doesn't
try
matter.
it
It's still
again.
going to be 0. 0 times
Okay.
anything is going to be 0.
Oh. Mm-hmm. Yep. How do
And
I
Hello,
yep.
kitty. Got a kitty
Okay.
here saying hello.
How do I close it? I don't see how you close this thing.
1 squared. 1/3 times 1 squared. Again, it's just 1/3 like we had above.
Um,
All right. And then our last one down here,
I want to share with you.
1/3
again. You guys
times
send it
3
to
squared.
again? Okay.
3 squared is 9 times 1/3. Go back to 3. So there's our points. -3, 3,
Okay.
-1, 1/3, 0, 0, 1, 1/3,
Take out
and
a
3,
trash.
3.
Oh, that
So
didn't do it.
let's go up here. So we have the point at 0, 0, and we have 1/3 at -1, and 3 is 3. So this is going from 3, 3 down to 1/3 to 0 to 1/3 to 3. Oh, oh. The last part wasn't real good. I just erased part of it. There we go.
Oh, wow. Okay, that's interesting. That was not what I thought that was going to be.
Okay, here we go.
Oh.
All right, so what this
Okay.
does is instead of the graph
And
being
now
like
giving you
this,
access, something
it's
might
spread
pop
out
up.
more like that.
Click on it this time. Oh.
This is spread out more by 1/3. It's compressed. What was up here got pushed down to here. What
I
was
guess
up here
I
got
might
pushed down to here. So all the points, like on the original graph,
I'm gonna just put this over
like here,
Okay,
when we
you
see
joined it. Okay, this
1,
is
2, 3,
you know
1, 2, 3,
this
4,
is
see, this is 9.
improvement.
This is the point 3, 9 up here. On our graph, 3, 9 became 3, 3.
I'm trying to
Oh,
see if I can
I
put
did 2, 3.
the-
That's why it looks funny.
oh,
Yeah, let me take this out further. I didn't even spread it out as
Ooh,
wide as
wow.
it should be.
what
I went to
the-
2, 3 instead of
Okay.
3, 3.
That was not what that was going to be.
There we go.
Okay. I was trying to
This
see if
goes
I
all the way
can
up to
put
3,
the
3.
worksheet on here.
If you do split screen.
So the point that used to be 3, 9
I was
way
trying
up
to put it
here
on the
has now
Jamboard,
been
so hang
compressed
on.
down to where it's only 3, 3. And negative
Yeah,
3, 9 up here is
This is
compressed.
just a
What used to be
less-
1, 1 is
this
now,
just, we're learning.
1, 1 is now 1, 1.
And it's a
third,
learning
Negative
opportunity
1,
here.
1/3. Everything has been
I help you,
compressed
but I've never done this ever before.
because
so.
I've
our
never tried to put a
A
document
is
on
less than 1.
Jamboard, so
The
we'll
absolute
just see
value
how
of
this
1/3
goes.
is 1/3. So 1/3 is less than 1. We've compressed
If I
it.
can find stinking.
So let's put in
document.
our
Okay, why
answers
are
over here.
you-
Our vertex
Oh,
is still at 0, 0 because we didn't
select a file.
we didn't
I'm
move
trying to
anything
select
left to
a
right
file.
or up
You're
or
not
down.
letting me
All we did is a
know what
compression.
kind of file you want.
So our axis of
Because you're
symmetry
not
is still
allowing.
x equals
Okay,
0.
we're gonna- there you go.
And
Yeah,
our
you can do
y-intercept
that.
is still 0, 0.
Okay.
And how does this compare to the parent function? Parent
I would
function,
really love it if I
which is x
could.
squared,
Where'd it go? Oh,
has been compressed by 1/3. Compressed by 1/3.
okay. So
So that's what happened to our parent function there.
can you see that?
So there we see what the A does,
The
what
doodle
the
I
H
just put on
does,
there.
and
Can
what
you
the
see
K
that?
does. The A is the compression or
There's
stretching.
nothing on here
The
anyway.
H moves it left or right. The K moves it up or down.
No.
So let's
I
look
might have
over
pulled
here.
up the wrong Jamboard. It's showing me both Jamboards.
Describe the
So
effects from the parent
I
function
didn't know
by
which
just
one you
looking
were
at
on.
the equation. We're not going to graph it. So this is x squared minus 3. Minus 3. Well, if we look back at that, that would be a K
Okay.
effect, right? Because it's after the x squared plus K. So let's say what's going to happen here.
Oh, there we
Nothing?
go.
Do you see me writing oxygen?
Yes.
Okay, fine. Okay.
Oh, no, I don't want that big. I know it's going to change it. a little
Okay,
bit.
so-
Make it like this. Okay.
Okay.
The parent function, x squared,
I just want to make sure that
um,
the first one you did is okay.
shifted down 3. Right? That's
So-
what happens with that. Here, we can move that up.
So after the ABC
Minus 3,
and A,
that means
oh,
it shifted
AB,
down
AB,
3. And here we've
and then
got
we get
x
to-
plus 1. So what is our h? X plus 1. This is x minus h.
Okay, we're
We're going to fall into this thing over here to where if it's negative, it's going to appear as a plus. So in this case,
Okay.
we're seeing an h equals
Okay.
-1 because x minus -1 would be x plus 1. So in this case, let's just that again here.
No.
The parent function x squared is shifted plus 1, so the left 1 unit. Let's actually put units in here
Okay. Well, go ahead and go to
because it's -1, so it's shifting it left. Right? When you see a plus 1, that means it's going left because the h is negative. You see a -1, it's going right because the h is positive. Then we have -2 x squared. So this is the A. The A. We've got two things going on. It's -2. So if one thing, it's less than 0, so it's going down. But the absolute value is greater than 1, so it's a stretch. So let's enter that on here. Let's see. Give ourselves some room to type there.
So
The parent function, which is x squared, is reflected over the x-axis, which means it opens down. right? And stretched times 2. So the 2 means it's being stretched. It's going to be, instead of like 3 9, it's going to be 3 18. Instead of 2 4, it's going to be 2 8. All those points are going to be stretched times 2, and it's going to be opening down or reflective of the x-axis.
Yes, 4 and 2,
In this case,
and then
I guess I really should say it doesn't always reflect over the x-axis. It reflects over wherever the vertex is. Reflected over the vertex. Let's say that way. Vertex. Because if the vertex has been shifted up or down, it's going to reflect over the vertex, not over the x-axis. It's only when the vertex is on the x-axis. Is that true? So let's say that correctly so we don't mess ourselves up there.
And then
All right. So that is how you describe the effects of the parent function. And I think we have either in the test or on one of the problems that has us to write, compare the parent function using appropriate vocabulary. So we have to write something like this to say what is happening to it. We're not graphing it. We're not doing points. We're just saying what's happening with it by looking at the equation. So we should be able to look at the equation and know what kind of transformation has occurred. And that's where you write these transformations like this. All right, so here's another one we're going to graph. And we've got all of it going on here. We've got a 2 up front. We've got an h that is equal to 1, and we have a 2 back here as the k. So if we look at that, a equals 2, h equals 1, k equals it's a plus 2. All right, this is a positive, and that's a positive. So they're all positive numbers because x minus h, right? So h is a positive 1. So what's happening here? We are stretching it times 2. We're shifting it 1 right, and we're going up 2. So the vertex, which would normally be at 0, 0, normally would be 0, 0, we know has shifted to now would be up 1 and over 2. I'm sorry, up 2 and over 1. So we go to 1, 2. Our vertex has moved. Everything has moved right 1 and up 2. Right 1 up 2. So that's wherever, and it's going to be doubled. So when we do all the points to the left or right of it, right? So normally our next point, when we had our parent function, 1, 1 was our next point. And after that, we had it's x squared. So if the x is 2, squaring is 4, that would be our next point. Right? And you can make a table if you like. We've got room here to make a table. We just didn't put a table on the page. So you get to look at that. So what happens to it? If it goes right 1 up 2 and is doubled from 1, 1, so this would have become 2, 3, except for doubled that, right? So that became 2, 6. No, that's not right. Let's look at the point. 2 minus 1 is 2, 2 squared, and 1 squared, 2 plus 2. It's gonna be 4. I really need to work the equation. If the x is going to be 2 now, because we've shifted it to the right one, 2 minus 1 is 1. 1 squared is 1. So 2 times 1 plus 2 is 4. On this one, if the x is 2, so that becomes a 2 right in there. 2 minus 1, I'm sorry. Our x is going to be 3 now because we shifted the right one. So 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8. Plus 2. All of our points when we make an XY table, because that's really what we're doing. We're making 1, 2, 3. And then you do negative 0 and negative 1 because everything shifted over 1. 1, 2, 4, 3, 10. It's going up a lot faster. On the other side, you're going to have the same points. You're going to have a 0 and negative 1, 10. And that shouldn't look like a V. It should be rounded. Should be rounded. But when we graph it, it looks something like that, which we can, you can go to Desmos and see that 2x minus 1 squared plus 2 is going to be graphed just like that. And we'll look at that in just a second here. Let's go ahead and fill in our vertex. We know the vertex is moved to 1, 2. The axis of symmetry is going to be at x equals 1 because it's whatever the h is, right? And the y-intercept now is going to be at 0, 1, 2, 3, 4. If we put 0 in, 0 minus 1 is negative 1. Negative 1 squared is 1. 2 times 1 is 2 plus 2 is 4. So how's this compared to the parent function? All right, let's write this up. The parent function, x squared, is, we know it's shifted right 1 unit, up 2 units, and stretched times 2. Right, shifted right 1 unit, up 1 unit, or 2 units, and stretched times 2. Just looking at the equation, knowing what the A, the H, and the K do, we can write that up, and then we can just draw it that way. So let's go, while I have this here, let's go to Desmos. So y equals, and we had 2 x minus 1 squared plus 2. Okay, there's what we just looked at. We set this to where we can go by ones, and so it looks like a normal graph. Go out the minor grid lines. Okay, there we go. So 1, 2, that was our vertex. Our y-intercept was 0, 4. You know, we had the point. I get right on the point. 2, 4. Where's that? There it is. 2, 4. And then we had 3, 10 way up here. 3, 10. So that's the graph that we were trying to do by hand just a moment ago. So let's go back. All right. One last page here. Graph this, graph this. So what we have is 1/2 and plus 1. So the plus 1 raises it up 1. And the half is going to compress it down. So if we just stretch, we do a sketch of that. It's going to go to plus 1, and it's going to be wider. It's wider because this is a 1/2. It's less than 1. We see this. There's no stretch or compression. We got an x minus 3, which means it moves to the left. I'm sorry, it moves to the right 3 because h is a 3. A positive 3, and it goes down 2. So 3, 2 would be our. Well, that's terrible. That doesn't look like a parabola at all. 3, negative 2, right there would be where the vertex, our parabola is, and it would not be stretched or shrinking. Now, this has none of these. Compare this to the parent function and use appropriate vocabulary. So let's see if we can do this properly. Okay, so obviously the parent function is x squared. Squared is, let's see, shifted left 1, because that's plus 1. So that means h is negative 1. H is negative 1, so shifted left 1. Up 7, okay, because we got plus 7 at the end. And then we have a negative and a 2/5. Compressed by 2/5 and reflected, let's say reflected down. Well, not say reflected over the vertex, just reflected down. So that would be over the vertex automatically. Reflected down. Okay, and then let's put that one. Let's put that one into Desmos just to see that. And we said it's left 1, up 7, compressed by 2/5 and reflected down. So we're going to shift that real quick to Desmos. Okay, so it's negative 2/5. And it was x plus 1, which is the same thing as x minus parentheses negative 1. Right? Because that's really what x plus 1 is. So if you want to see, that's
Almost
squared. Ooh.
So you have to put these numbers.
There we go. X minus a negative 1. It says x plus 1, but that's the same thing to show us that it's going left. And then we said a plus 7 at the end. Okay, so here it is. It's a little wider than the normal one. So let's look at the normal graph. Y equals x squared. All right, if we just made that a reflection downward and did the same modifications, let's do x plus 1 and go plus 7 at the end. So there's the same translations as far as shifting it left 1 and up 7, but the blue one would just be x squared. The red one is the negative 2/5. See, the blue one is just the negative 1. So you can see it does compress it because instead of this going down one whole unit, it only goes down part of a unit, 0.4 of a unit. It's compressed. Everything is squeezed out. It's stretched wider, but it's compressed. When we talk about up and down, it's compressed up and down. So we can see the difference on there. But we see the translation. We said it went left 1, up 7, compressed by 2/5, and reflected down. And it is reflected over the vertex. If we take off the minus, it's the vertex is the point it's reflected over. All right. Okay, so that's all of the notes. These completed notes, by the way, will be posted to Google Classroom in about 15 minutes. I'll get them all in there. So you will have all of this notes that we just did on the Jamboard. You'll be able to look at them on Google Classroom. So you'll have them all. So they'll be there, and so you can refer to that. Let's look at our assignment while we're here then. And you have 4 different sections here. Each one of them are very similar. So given C of x equals x squared. So there's your parent function. Write the equation of the function created after each step. So first, reflect C of x across the x-axis. All right. Right now, this is the origin of 0, 0. We just want you to reflect that. And then call it A of x. So when you're doing a response for this, your response would be A of x equals. Because I told you to call it A of x. I told you what to name the function. So you would put A of x equals as part of your answer. And then put whatever equation would reflect that over the x-axis. Then the next part of this, shift A of x to the right 5 units. A of x is what you just wrote. So you would take the equation you wrote and shift it right 5 units. So you need to make whatever modifications to that equation that would make it shift right 5 units. And then you call that one T of x. See T of x right there. So then you take T of x and shift it down 2 units and call this S of x. All right, so S of x would go right there. And then finally it says sketch the graph of S of x. All right, and now let me show you how this works. I want to show you how this works on formative. The first thing you want to do is put your vertex. So let's say, and I haven't done all of this, but let's say our vertex is the point 4, 4. I put a point at 4, 4. Then let's see, what did I do? I reflected it down. Okay, so then I would take a second point and I'm going to put it down here. And I can move this point to make it as wide or skinny as I want it to be. So what you probably ought to do is calculate 2 points. The vertex and one other point. Substitute an x into your final equation and get one other point. And if you put those 2 points on here, it will graph it for you. If you just graph those 2 points. You can't graph more than that. It only lets you do 2 points. I can click all I want. That's all it graphs. And it will make it a parabola automatically for you. So you need 2 points. One is the vertex and then any other point. So substitute, get your vertex and any other point. And your vertex is HK. Whatever your H and K are is your vertex. Remember that. So graph it right there. And then you go to the next one and you have the same thing. You're starting with x squared minus 4. And then you're going to shift it left 4. And name that b of x. And then take b of x and go up 1 and call that c of x. And take what are the coordinates of the vertex of c of x and then sketch that graph. So you have 4 of these to do where you end up sketching the graph after each one. All right, 4 different ones. That's the big picture. That's looking at everything we have this week. All about transformation. Like I say, you'll have these notes on Google Classroom in about 10 minutes or so. Have those posted there that you can look at, refer to if you want to print those out, whatever you want to do to help you do the assignment. So, all right, right now as it stands, and weather can change this, Thursday is the conference bowling tournament. So I will not be here Thursday. We will not have class Thursday. That could change. Weather can change it. It was supposed to be tomorrow, and it's already been changed to Thursday. It could be changed again, but I will send an email out for sure, letting you know. So, but that's it. If anyone's got any questions, I'm happy to answer them. Otherwise, go enjoy your ice.